Hello guys, welcome to the DMS online school. It's a long time I uploaded such a great video like this one, guys. So guys, if you didn't know, we have actually clocked 100k plus subscribers on this channel. So thank you so much for supporting the DMS online school. Thank you so much for sharing the videos. Thank you so much for liking, commenting, and everything that you're doing. Though views in Zambia, they don't count, but the number of views on our videos and the number of comments and sharing and of course subscribers shows how many people we are helping in Zambia and around the world. So thank you so much for supporting the channel. Without you, this channel can be nothing. Okay, so for those of you that are new to this channel, you're welcome. On this channel, I revised past examination papers just as I'm doing in this video, and also teach actually topics like physics, chemistry, mathematics, RE, English, and civic education. So in today's video, we are just going to revise this paper. Okay, so if what I do on this channel is what you're interested in, please consider clicking the red subscribe button below and turn on the bell notification so that when I upload a new video, YouTube will be able to notify you. Okay, so today's video says Examination Council of Zambia, examination for General Certificate of Education Ordinary Level, Science Paper 2, the paper which was written on the 7th of August 2024. So without further ado, let's go straight into the video. Okay, so before we go any further, this video is not for those people who have a short attention span, people that are meant to watch just short videos, seconds, they're done. No, it's for the people that want to gather knowledge in this world. They want to study, they want to learn, they want to be knowledgeable. So for those people, please hang on up to the end. I promise this video is going to provide value to you. So please remember to like, remember to comment and share so that many people can also get value from this. So let's go straight into this revision. A1 says, which branch of chemistry would a grade 12 learner intending to become a pharmacist study? So which branch of chemistry would a grade 12 learner intending to become a pharmacist study? A, analytical chemistry, B, biochemistry, C, organic chemistry, D, physical chemistry. Okay, so the answer actually here is B, biochemistry. So when someone wants to become a pharmacist, what will be their job, or what will they encounter? They will study how to the chemistry which is involved in making drugs, okay, like medicine, so to say. And for them to be able to understand how drugs work, they have also to understand how a human being works. And for them to be able to have these two fields in one, they need to study this field which is known as biochemistry. Then A2 says, which of the following shows the correct basic unit of matter contained in the stated substances? Now, many other times pupils fail questions. Why? Because they fail to understand, number one, the topic the question is coming from, and then number two, the context in which the question is being asked. So this question says, which of the following shows the correct basic unit of matter contained in the stated substances? So the put substances are here. A, boron, B, mercury, C, methane, then D, neon. Then the basic unit of matter are here, ions, molecules, atoms, and atoms again. So you must understand that in this nature or in the universe, substances that are there can be either in compounds, can either be in mixtures, can either be in elemental form. So those that are in elemental form, for instance, like neon here, what type of basic units they have? Atoms. Those that are in compound form, like methane here, what type of atoms they have? In most cases, if the type of bonding they have is covalent bonding, then they'll have molecules. So methane doesn't have atoms, this is wrong. When we go to mercury, mercury is actually a metal. So as they mention as mercury here, it's an elemental substance. So if it is an elemental substance, what type of basic unit are found in it? Not molecules, it's just atoms. Okay, when we go to boron, boron again, it's an elemental substance. So if boron is an elemental substance, what type of basic unit of matter are there? It's just atoms, not ions. Ions are found in substances that are in compound, which are formed as a result of ionic bonding. So when we look at these now, what would be the correct answer? The correct answer would be D here, because neon is the one that should have atoms, then methane should have molecules, mercury should have atoms, then boron also atoms. All right, so let's proceed to the next question. Question A3. This question is one of the questions that I've encountered in many examination questions that I've revised on this channel. If you go through my channel, you'll discover that I have revised many examination question papers, because my nature of revision is to revise the question paper from question 1 to the last question. And I've seen many questions, and one of the questions I've seen being repeated is actually this one here. Okay, so this now reminds me of the importance of revising through examination papers, because as you revise through these examination papers, you are going to see how most of the questions are repeated. Okay, and it is going to give you what we call an edge or an upper hand than your friends that have not been revising, in terms of how you are going to score in your exam. This is why most people get good grades like distinctions, because of revisions. And what I do on my channel here is to provide revision videos from 2015 to 2024 in one package. Then I give that to you at 120, explained very well, to help you to pass. So if you are one of those that wants to pass this year, you can contact me on 0977 924175 to get this revision package. I have another one, topic by topic, where I've compiled questions from the same topic, put together, answer them. Another topic, compiled all the questions, answer them, so that you understand how questions are brought on each and every topic, and then how to answer those. That's how it is. And that one also is going at 120, and you can contact me on the same number, 0977 924175, to get that revision package. If you are one of those going to GCE or one of those going to write grade 12, this is very important for you, to give you an edge or an upper hand in writing the exam. So let's proceed. So A3 says the following diagram show volumetric apparatus. So which apparatus measures only approximate volumes of liquid? So this question is coming from experimental techniques or common apparatus that are found in a laboratory and their uses. So we have to know these apparatus by name. This one is a burette, which is used to measure accurately volumes of liquid, especially in titration. Then this one is a measuring cylinder, which is used to measure volumes of liquid where accuracy is not required. This one is a pipette, which is used to measure accurately fixed amount of volume. This one, the way it is, it looks as though it is a volumetric flask or it is a conical flask. If it is a volumetric flask again is not for measuring volume, it's for preparing standard solution. If it is a conical flask, it is just used for reactions. So we rule out D and then concentrate on these three. We rule out this one because the question says which apparatus measures only the approximate volumes of liquid. This one accurate, this one accurate. So the correct answer for which measures approximate volumes of liquid where accuracy is not required is actually B here. Okay. Then we move on to a form which says which mixture can be separated into its components by adding water, stirring, and filtering. Okay, so this question again is coming from a topic known as separation technique. So you are told to say which mixture can be separated into its components by adding water, stirring, and filtering. So A, we have iron and sodium chloride. When you look at iron, iron is a metal. And iron is a metal which is commonly used to make even containers. So if you get iron, put in water, what happens? Does it dissolve? No. Because when you look at, they're telling us which mixture can be separated into its components by adding water, stirring, and filtering. So this means that this method we are discussing here is filtration. And if we're discussing about filtration, we need to know a method, or we need to know type of mixtures that can be separated using filtration. So what are these type of mixtures? These are mixtures that involve a liquid and an insoluble solid like sand and water. Okay. Now, in this case, if we look at the option A, iron and sodium chloride, does iron dissolve in water? It doesn't. If you get iron, mix it with sodium chloride and put in water, stir, what will happen? Sodium chloride will dissolve, whilst the iron will not, right? Now, can you separate iron from sodium chloride by filtration? Of course, yes. Let's try first B. We have iron and sulfur. Sulfur is a nanometal. If you put it in water, does it dissolve? No, it doesn't. Okay. Then, if iron and sulfur, they are not dissolving, and you try to filter so that you can separate them, can they? No. Then you have C actually. So the answer is A. Then C, potassium carbonate and calcium nitrate. These are two salts which are soluble. So if you mix them, add water, stir, they'll all dissolve or both dissolve. You will not be able to filter them. Then D, you have sodium chloride and copper 2 sulfate. They are both soluble salts. When you put them in water, you stir, they'll both dissolve. You'll not be able to filter them. That's what you must understand here. And this is why science is one of the simplest subjects to pass. All right, so let's proceed to the next question, which is A5. A5 says an atom of element R has the electronic configuration of 283. Which of the following statements about element R is correct? So we have this element here, R, and it has electronic configuration 283. These are electrons. Total them up. 2 plus 8, 10 plus 3, it will give you 13. So which element in the periodic table, from your knowledge of chemistry, from grade 10 to grade 12 or to where you are, which element has got 13 electrons? Of course, it is aluminium. All right. So now, if they say which of the following statements about aluminium is correct, let's not go about R now. A, forms an ion of charge 3 negative. That's not true. Aluminium is a metal. And when metals are forming charges, charges are positive. How do they form charges? By losing electrons. Because metals are elements in most cases which have number of electrons in their outermost shell ranging from actually somewhere 1 to 3. That's how it is in metals. Number of electrons in their outermost shell will be ranging from 1 up to 3. And during bonding or formation of ion, they lose these. And once they lose those electrons in the last shell to form noble gas configuration, they actually become positive. They form positive ions. So when they say forms an ion of 3 negative charge, that's wrong. B, forms an ion with the electronic structure of neon. When you look at neon on the periodic table. Let's see if I have the periodic table here. Of course, I do not have the periodic table. How I wish I had the periodic table here, but I don't happen to have it. Okay, so neon has got 10 electrons and 20 atomic mass. So if you put those electrons in configuration, it will be 28. So if they're saying B forms an ion with the electronic structure of neon, meaning if aluminium is forming an ion, it will lose 3. It will remain with 28. And the neon also has 28. So the correct answer actually is B. So they're saying C is a nanometal. Aluminium is not a nanometal. D reacts with metals. Aluminium is a metal. Then we come to question A6, which says identify the diagram in which a pure element is in solid state. So we want to identify a diagram here in which a pure element is in a solid state. So we have diagram A, diagram B, diagram C, diagram D. Which diagram here represents an element in pure state, solid state? Now, guys, we need to understand that in nature, in life, in this universe, matter can be classified, number one, in 2 categories. It is either in elemental state or in compound state. Another category matter can be found is when you get 2 elements, put them together physically, they don't combine, you form mixtures. So in matter we have pure substances which can either be elements or compounds, and then we have mixtures which can be a mixture of 2 elements physically combined, or a mixture of an element and a compound physically combined, or a mixture of a compound and a compound physically combined. Now, you must know diagrammatically how we represent each of these. If you have, like in A here, you have this is an atom, that one is a different atom. The white one and the black one there, these represent different atoms bonded together. You see they have held it together. These have bonded together, meaning this substance altogether here, it's a compound. Okay. When we come to B, you see that these are same type of atoms that are bonded together. When you look at this, it's not actually a pure substance, this one. Okay, it can be a pure substance, but it's not an element. It's a molecule compound, this one. When you come here, you find that these are same types of atoms bonded together, and they're very close to each other. Now that they're very close to each other, they represent a solid. And since they are the same type of atoms, it means that this solid here is a pure substance, which is an element. When we come to D here, you will discover that we have black and white particles there, which means that we have different elements here being put together. Now, these elements are not attached to each other in a certain fixed ratio. They're just combined haphazardly or randomly. Because they're combined haphazardly and randomly, and they're not showing proper combination like here, it means this one is a mixture. So D is a mixture, C is a pure element, then B is a pure compound molecule, then A is actually a compound. So when they say identify the diagram in which a pure element is in solid state, the answer is actually C. Okay, so let's move to the next question. So A7 says, which of the following pairs of compounds would react together to form an insoluble salt? We have these pairs here: calcium hydroxide and hydrochloric acid. We have sulfuric acid and sodium hydroxide. We have sodium sulfate and lead nitrate. We have zinc chloride and sodium nitrate. They're saying which of the following pairs of compounds would react together to form an insoluble salt? Where is this question coming from? From which topic? Acid, bases, and salts. From which subtopic? Preparation of salts. Now, here they are trying to find out from us if we are able to understand solubility rules. Because when we understand solubility rules, we must be able to know which pairs of reactants, when put together, are going to lead to the formation of an insoluble salt. Okay? And I covered that topic on solubility rules here on my channel and also in my online class in detail, such that when you go through that lesson, you are going to understand these solubility rules. So when we say calcium hydroxide and hydrochloric acid, this is a base and an acid. So calcium hydroxide and hydrochloric acid will form calcium chloride salt, which is soluble. B, we have sulfuric acid and sodium hydroxide. Again, this is an acid and a base. These two, when they react, they'll form sodium sulfate salt, which is actually soluble. The next we go to see, we have sodium sulfate and lead nitrate. So these two are soluble salts, soluble salt and a soluble salt. These two, when they react, they are going to form two salts. One is sodium nitrate, which is soluble. Another one is lead sulfate, which is insoluble. So when they say which of the following pairs of compounds would react together to form an insoluble salt, it's actually C, because lead sulfate is an insoluble salt. So actually here the answer is C. But D says zinc chloride and sodium nitrate. If they exchange these ions, it will be zinc nitrate and sodium chloride. These two, zinc nitrate is a soluble salt, sodium chloride is a soluble salt. So the correct answer is just C. Guys, if you're enjoying this revision, remember to give it a like, comment in the comment section, share, and also remember to subscribe for more videos like this. A8 says, a given substance solution, a given sample solution was tested for the presence of an anion using dilute hydrochloric acid. If absence was observed, predict the anion present in the sample solution given. Where is this question coming from? The same topic, acid, bases, and salts, from another extended subtopic which is connected to this, known as qualitative analysis. So qualitative analysis is a topic in chemistry which deals with identifications of ions in compounds. So you can identify cations, which are positive ions, or anions, which are negative ions, using other compounds in the way they react, the gases they produce, the type of substances they produce in terms of color, and also in terms of solubility. So when hydrochloric acid is added to a sample, a given sample solution was tested for the presence of an anion using dilute hydrochloric acid, then they're saying if absence was observed, like bubbles. When they say predict the anion present in the sample solution given, when you get hydrochloric acid, you add it to a sample solution and you see bubbles, then what type of anions are there? It is actually carbonate ions. That gas which bubbles off, which produces effervescence, is actually carbon dioxide. So the answer is A. Then A9 says calculate the relative formula mass of ammonium sulfate, which is this one here. This question has also come in so many examination questions. Relative formula mass. What is the relative formula mass? It is the sum or the total number of relative atomic masses of the elements in a compound. Like we have elements in this compound. We have nitrogen, hydrogen, phosphorus. Then we have what? Oxygen. Each of these elements have got their own atomic masses, which you can know from the periodic table. Like for nitrogen, it's 14, hydrogen, it's 1, then phosphorus, 31, then oxygen, it's 16. So the sum of these is what gives us the relative formula mass. And the relative formula mass, for short, we just write RFM. R relative, F formula, M mass. So how do we find? We say equals. Then you sum up this one. Now nitrogen is inside the brackets. Outside there's a 3 here. So it means this 14, which belongs to nitrogen, you multiply it by 3 there. So say equals 14 times 3. Then you move on to hydrogen. As you move on to hydrogen, you say plus. Okay, hydrogen here, it has 1. And it has a 4 down here. So you say 1 times this 4. Again, outside this hydrogen, there's a bracket, there's a 3. So you say also times 3. So same, 1 times 4 times 3. You are done with this one. As you move to the next phosphorus, you say plus. Then phosphorus is alone, you just put 31 plus. Then you move to oxygen. Oxygen is 16 and it has a 4 down here next to it. So I say this 16 times 4, 16 times 4. Then you say equals. Now you add up everything here, evaluate, and get the answer to be 149. So relative formula mass does not have units. So in that case, the correct answer, which corresponds to our answer, is D. Then we move on to the next question. A10. Limestone, which is calcium carbonate, decomposes to calcium oxide and carbon dioxide when strongly heated. To decompose is to break down. You have calcium carbonate, you heat it, it breaks to 2 substances, calcium oxide and the carbon dioxide. Then they're saying, given that 500 grams of limestone, like this same calcium carbonate was 500 grams, given that 500 grams of limestone was decomposed, calculate the mass of calcium oxide produced. So what mass of this calcium oxide was produced? To do this well, what we do is to come up with the balanced chemical equation. Like you say, if I have calcium carbonate being decomposed, it will form to calcium oxide and the carbon dioxide. Okay, it will form calcium oxide and carbon dioxide, put plus. This is a chemical equation in symbols. Then you try to balance it if you can. You check calcium atoms here, how many? 1. Check here, how many? 1. So these are balanced. Don't balance them. You check carbon, see 1. How many carbon here? See, it's 1. Don't balance them. They are okay. Then you look at oxygen, there are 3 here, O and 3 here. You come this side, you find there's oxygen here, 1. There are 2 oxygen here. You combine 1 plus these 2 here, 3. So it is balanced as it is. So don't balance it. From there, this question says calculate the mass of calcium oxide produced. Which topic is it coming from? It is coming from a topic known as Mole concept. Now, under which subtopic? In our grade 10 to 12 current syllabus, they never put the subtopic well. The subtopic is supposed to be stoichiometry, where you look at calculating amount of reactant or products in a chemical reaction. It's a more concept under stoichiometry. So, to answer question under stoichiometry, for example, if you are given mass and then you are asked to calculate mass, it's simple. Just get the masses here. They need to balance the relative formula of this and this one and this one. When you add the relative formula of carbon and the calcium oxide, they must give you this one. But since they have given you 500, they want to know the mass of calcium that will be produced. First of all, find the relative formula mass of this. By knowing that calcium is 20, then carbon is actually calcium 40, carbon 12, then oxygen 16. Then here you know that calcium again is 20, then 40, then oxygen 16. Then what you do, you sum up this one. You say 40 plus 12 plus 16 times 3, you get 100. Then you say, okay, this is what is provided in terms of stoichiometry. Then this one, it leads to, you total up again this one, 40 plus 16, you get 56. So you're saying, okay, if I have 500, I'll get 56. Here, I'm sure you have 40 something, 44. So that when you have 56 plus 44, it will be 100. So, but you want to know the mass. You say, okay, 100 is for 56. But if I'm given 500, is for what? So, okay, what about 500 is for what? You put x there. Then you just cross multiply. You say 100 times x. You get 100x. Then you say equals, you introduce equals. You say now 500 times 56. You get what? You get 28,000 grams. And this question has been coming over and over. I've seen this question with the same amount. Nothing they are changing here. The beauty of revision. The beauty of revision. Those that have revised with me, if you're watching, comment in the comment section how those revisions have helped you to understand. Somebody might be helped also to purchase the revision package at 120, and you gain knowledge at 120, which will help you in your entire life. 20 kwacha, 120 can be used and wasted, forget. But if you use it in a good way by getting knowledge, then that knowledge will empower you for your lifetime. Okay, so now, when you reach here, you need to know x. So you divide by 100 here, and also by 100 this side, so that this 100 and 100 cancel, you remain with x is equal to 100 into 28,000, you get actually to 280 grams. So this is the mass of calcium oxide that is produced. When you look at 280 grams and here, 280 grams is here, so our answer is C. So we move on to question 11 or A11, which says, the following graph was obtained when powdered calcium carbonate of equal volume and mass was reacted with hydrochloric acid at different concentrations. Okay, so we are being told that this graph was obtained when powdered calcium carbonate of equal volume and mass was reacted with different concentration of hydrochloric acid. So they came up with this graph here. Now, this question is coming from a topic known as rate of chemical reaction, which is a topic dedicated to understanding factors that affect how slow or faster reaction go. And this topic has come to identify the factors that affect chemical reaction as number one, size of particles. The smaller the particles, the faster the reaction. Two, concentration. The higher the concentration, the faster the reaction. Then three, temperature. The higher the temperature, the faster the rate of chemical reaction. Then we have four, pressure. The higher the pressure, the faster the rate of chemical reaction. Then we have five, we have catalyst. If a catalyst is present, the reaction can also go faster. These are factors that affect reactions. Okay, understanding these factors can help you in life very much. Okay, now when also it comes to understanding very well reactions, we can also plot them with time, of course. Time against a certain variable. It can be volume, concentration, pressure, temperature, catalyst, or something like that here. But here, time. So when you come up with graphs such as these, a steeper graph like A here, very steep with high gradient, it represents a faster reaction. Then a flat graph like this one D, it represents a slower reaction. Okay, So when we look at this question which says identify the graph which represents the reaction between powdered calcium carbonate and hydrochloric acid of the highest concentration. So here you understand to say, okay, equal volume or amount of calcium carbonate was being reacted with three of them hydrochloric acid of different concentration. Now, the one with the highest concentration should be the one providing the faster reaction, which is A. So when they say identify the graph which represents the reaction between powdered calcium carbonate and hydrochloric acid of the highest concentration, the answer will be actually A. Then we move on to A12. A12 says, how does a catalyst increase the rate of a chemical reaction? It does this by A, increasing activation energy. No, the answer actually here is B. So, a catalyst increases the rate of chemical reaction by lowering activation energy. Let me put it in a layman's understanding. A car would find it very hard to go up a hill than on its own than when it is being assisted by some push-up by another car. Okay? So in that case, if a car is given a push by another car, it will find it easier to go up that hill than when it is not given a push. So in that case, the car engine, when a car is given a push, will not feel the impact of going up the mountain because a push has been provided. In that case, it will feel as though the mountain has been lowered to it and it will pass very well. That's what a catalyst does to chemical reactions. It gives chemical reactions a push so that reactants can react to provide products. And in such a process, reactants feel as though the energy needed to combine has been lowered, yet it has been boosted by the presence of a catalyst, such that now the reaction has gone faster. Okay? That's what it does. So it lowers the activation energy. Then A13 says identify the correct electronic configuration of an element used to treat water. Guys, these are bonus questions in an exam. We know an element which is used to treat water in homes is actually chlorine. Now, what is the electronic configuration? Arrangement of electrons of chlorine in shells. So the element used to treat water is chlorine. Then chlorine is a Cl with 17 electrons and atomic mass 35.5. So 17 atomic mass means it has electrons 17. So say, okay, we'll use the atomic number 17 to come up with electronic configuration with the rule that the first shell should have 2 electrons, the second 8, then the third 8. If there are more electrons, it can even go to 18. Okay? Now, in this case, let's put these 17 electrons in shells. So we'll come up with this electronic configuration. 2 in the first shell, then 8 in the second shell, then 7 in the third shell. Which configuration in here matches ours? It's actually C. So the answer is C. Then we move on to A14, which says the following diagrams show different experiment setups used to investigate conditions necessary for corrosion of iron metal to occur. So corrosion is actually wearing out of iron due to oxidation, or when iron reacts with either water or oxygen, it undergoes oxidation to form iron oxide. When it forms that iron oxide, it actually like rust. It corrodes iron. It makes iron to wear out. Okay, so this experiment here was set up to investigate conditions necessary for corrosion of iron metal to occur. There are actually about 2 or 3. Iron can corrode when there's water, oxygen, and also in the presence of salt. So when we look at the setup A, we have a layer of oil, which previously boiled water here. Then we have iron in nail. Then we have what? Boiling tube. So boiled water means it doesn't have oxygen here. Okay? So you put a nail there. They've closed the layer here to prevent oxygen coming in there. So if there's only water, no oxygen present, rusting will not occur. B, we have iron inside water here, water and boiling tube, and nothing is closed here. Corrosion will occur here. Okay? Then, because there is oxygen will come and there is water. Then C, we have boiling tube, we have iron, we have salt water. So here also corrosion will occur. Now there's also salt. It will act like a catalyst. So in D, we have dry cotton wool, that one, iron nail, boiling tube, nothing else, no water. It will not occur. Predict the experimental setup in which the iron nail will corrode the fastest. Here to corrode, here to corrode. But here, because there's presence of salt, it will be faster in C here. So the answer is C. We proceed. A15 says, in which of the following pair of reactants will a displacement reaction take place? A displacement reaction, guys, is a reaction in which a more reactive substance removes a less reactive substance from its compound or salt. So, we want to know a pair of reactants which will undergo displacement reaction. Is it M, where we have aluminium nitrate and magnesium? Here, if magnesium reacts with aluminium nitrate, will magnesium displace aluminium? Yes, because in the reactivity theory, magnesium is more reactive than aluminium. So here A agrees. In B, we have copper sulfate, copper to sulfate, and the silver. Silver is less reactive than copper, so it can't displace copper here, so no displacement reaction. In C, we have magnesium sulfate and copper. Copper is not more reactive than magnesium, so no displacement here. Here we have zinc sulfate and iron. Iron is not more reactive as compared to zinc, so no displacement here. So the correct answer is A, because magnesium will displace what? Aluminium to form magnesium nitrate and aluminium. So A16 says the diagram shows the reaction of a gas T during its production. Okay, so we have a gas here, T is produced gas jar here, delivery tube. Then they're saying what interpretation can be drawn from the method of collection of the gas? It A has a dense equal. A has density, it has a density equal to that of air. No, this method of collection, we call it, I think it's upward displacement of air, or downward, so to say. This air comes here, then the rest of the air here will be pushed down. So we can say downward displacement. So this method, the air is going up. For the air to go up like that, it means this air is less dense than the air here. Okay, so this is not correct. So B, they're saying, is denser than air. So if that gas is denser than air, it can't go up. Then C is less dense than air. Yes, that's why it is able to go up. So the answer is actually C. Then they're saying D is slightly soluble in water. Maybe, yeah, it is slightly soluble in water, but not really. So this is very important concept. Now, if I were to ask you guys to say, oxygen is one of the gases which is very common in the universe. And then I say, air is a mixture of gases. Is hydrogen among these mixture of gases in air on Earth? What would be your answer? No. No. Where has hydrogen gone? Because hydrogen, being the lightest gas which we have on Earth, it has gone on the upper of our atmosphere. And most of it, actually, it is in outer space. Because it is lighter, so it is up. It has been able to go up, displaced up there. So it's very important you understand that as a science student. We go to A17. Why is hydrogen referred to as a clean fuel? Because it A, burns in oxygen to give more energy. That's not really the truth. B, does not pollute the environment. Yes, something which is environmental friendly, it can be referred to be clean fuel. So the answer is B. Then A18 says, the chemical compound which can best be used to make hand sanitizer is what? It's actually alcohol. And the answer is D for alcohol. Alcohol is what has been used to make sanitizer. Even in the period of COVID, we witnessed alcohol being expensive because was one of the components which was being used to make sanitizers, and the drunkards were even boasting to say, us who are drinking alcohol, especially cachasu, we are not suffering from COVID because our cachasu is able to sanitize our body. As we drink any COVID-19 that is found along our esophagus, it is actually sanitized. Okay, or alimentary canal, it is sanitized. Of course, that one used to help, but it wasn't reliable. So let's move to the next one. A19. Large petroleum molecules undergo cracking to produce smaller molecules which are more useful. What would be product X when the hydrocarbon C20H42 is cracked according to the following reaction? Okay, so in this reaction we have this hydrocarbon C20H42 being cracked to produce hydrocarbon X and hydrocarbon, this one here, which is the butene. They're asking us to know what is X here. Cracking is the breaking down actually of larger saturated hydrocarbon to produce actually shorter chain saturated hydrocarbon, which have got more use than a longer chain. Like when we talk of petrol and diesel, which one has got a more use? Of course, petrol and oxygen and diesel, they are both useful, but there's one which has more use. When we go to most of these filling stations and to look for petrol, you discover that in these days, petrol will not be there, while diesel will be there. Why? Because petrol has more use. Now, in such a situation, in developed countries with developed technology, diesel can also be converted to petrol. So that is the concept under cracking there. So longer chain hydrocarbons can be cracked so that you can produce shorter chain hydrocarbon in most cases that have got more demand than longer chain ones. That's the concept around cracking. That's why cracking was developed, just to give you an idea. Now we have this longer chain being cracked here. So simple question here. So simple. Why? Because the total number of carbon atoms this side must be equal to the ones this side. Total number of hydrogen this side must be equal to this side. So if here we have 10 and here we have what? 42. Then we have 32 around here. If here we have carbon 20, then here we have just 4. Then we have 16 around here. So how do we put that hydrocarbon now in perspective? So the answer now will be like this. Replace this one with a CXHY like that. So that now, from there, what do you do now? You balance C and H. You say like, if I have 2 times X plus 2 times 2X here, 2 times this X per carbon, plus 4 here, it should give me 20. That's what we have done. 2X plus these 4 around carbon should give me this 20. So, which will be now, the 20 will pass that side. We'll say the 4 will pass that side. We'll say 20 minus 4, it will be 16. Then 6 into that, it will be 2 into 16, it will be 8. But you can, yeah, that's that. Then here you can also say the same, 2 times y. Then you say that one plus 10 here for hydrogen now. It will give me 42. Then this 10 passes there. You say, okay, 42 minus 10, you'll get 32. Then 2 to get y, 2 into 32, you get something like 16. So meaning C is 8, then H is 18. So which answer here now? It is D, C, I mean, there. Then we go to 20. 20, they're saying, the diagram shows part of a polymer. So this is part of a polymer. Which of the following monomers would be used to form this polymer here? So this question is coming from polymerization, addition polymerization, which unsaturated hydrocarbons undergo, like alkenes. Now, this type of polymer is formed by repeating units. So which repeating units? Repeating units are called monomers. You find that this one is similar to that one, is similar to that one. So in each of these, we have what? We have a chlorine, chlorine, chlorine. So polymerization is formed when these monomers were joining together. But before they were joining, or before they joined, they had double bonds. That's why they call them unsaturated, because of double bond which they are readily able to break. So if you get this half, this half here, you bring it here, and this half here, you bring it here, you form a double bond. So it will not be there. So this part will look similar to this. So if they say which of the following monomers would be used to form the polymer, it will be actually A, not these others. This one has got a 2 chlorine. There's chlorine, chlorine, and here we don't have such. Here we have single bond, no. Here double bond, but because of chlorine, chlorine, it doesn't qualify. So we move now to section B, 45 marks. Answer all questions in this section. Write your answers in the spaces provided in this section paper, question paper. B1, a box of chemicals in a laboratory has the following symbol attached to it. You find a box that fits this symbol here. Then they say, A1, describe the nature of chemicals in the box related to the symbol. So when they put this on a box, what is the nature of chemicals in that box? It means that the chemicals are flammable. They can catch fire easily. That's the symbol here, like petrol. Then 2, write a laboratory rule that is observed when handling chemicals in this box. When handling these chemicals in this box, what laboratory rule are you supposed to follow, since this is flammable like petrol? What laboratory rule do we have, or what rules do we have in handling chemical, something which is flammable like petrol? So it's similar. Keep all containers well sealed and away from open flames or heat sources, so that this one doesn't catch fire. Let's move. B. When a bottle of ammonia is opened, within a few minutes, its smell spreads throughout the laboratory. You open a bottle of ammonia, within a few minutes, its smell spreads throughout the laboratory. 1. Name the process responsible for the evenly spreading of the smell of ammonia. What process is involved in the spreading of ammonia? That is diffusion. Then B, describe the process responsible for the even spreading of the smell of ammonia solution. So this we describe now diffusion. We say diffusion is the movement of molecules from a region of high concentration to a region of lower concentration. Then Roman numeral 3, they're saying relate the evidence which the process named in B1 provides to the kinetic theory of matter. Relate the evidence. So diffusion is an evidence to the theory of kinetic theory of matter. Why? Because the kinetic theory of matter states that matter is made up of tiny particles which are in continuous motion. And diffusion is one of the evidence that proves this assumption here. So when they say relate the evidence which the process named in B2 provides to the kinetic theory of matter, we'll say now that diffusion shows that gas particles are in constant random motion, colliding with one another and spreading out just as the kinetic theory predicts or states. Then B2, the following diagram shows a piece of apparatus used in the laboratory. We have this piece of apparatus here, stopper, tap here. And this question also has been coming so many times. Then they're saying, A, name the piece of apparatus shown in the diagram. This is a separating funnel or separation funnel. Then B1, identify one property of a mixture separated by the piece of apparatus named in A. So like this piece of apparatus separating funnel, what property do mixtures have such that they can now be separated by this method? So we can say that it separates liquids that are immiscible. Liquids that do not mix, like if you get water and cooking oil, you mix them, you shake them. After some time, you'll discover that oil will be alone and water will be alone. So such liquids that do not mix, we call them immiscible and can be separated by separating funnel. Then Roman numeral 2 says, suggest the names of two liquids that can be separated by the piece of apparatus shown in the diagram. So we said water and oil, or water and kerosene, etc. Okay, then let's move to the next question. C, suggest two precautions that need to be taken to separate the mixture. So when you are using this method, what precaution can you take? First of all, close this before you put the liquids there. Then secondly, this one you should open it. Then thirdly, you should allow the mixture first to settle. Like in a case of water and cooking oil, if you shake them, you allow them to settle for them to separate well so that you can separate them. So precaution number 1 is that always check that the tap is fully closed before you pour the mixture in. Then secondly, they needed only one, but I've provided more. remove the stopper from the top of the separating funnel before opening the tap to drain the lower layer. Why should you remove that? So that you allow now the liquid to come out. Then thirdly, allow the layers to settle completely before attempting to drain the layer or the lower layer. Then we come to B3. The following diagram shows the electronic configuration of the ion of an element M. Okay, so we have an element M and its electronic configuration. An ion of element M and its electronic configuration is this. We have how many shells? 1, 2, 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then we have a positive charge of 2, meaning that this one had the total number of electrons 20. 2 were in the last shell, but they were lost, and that's why it developed a charge of positive 2 here. Okay. Now they're saying A1, draw the atomic structure and write the electronic configuration of the neutral atom of M. So they want us to reverse back this one to the way it was before it became an ion. So put it like this. This is the same that one. Then the first shell, third shell, second shell, third shell, fourth shell. So in the first shell, there are 2 electrons as there. Then here, there must be 8, like that. In this shell, also 8 electrons, like that. Then in the last shell, it should have 2, which were lost. So this is the structure of an atom before it became this. So it lost this to look like this and form ion. Then they're saying electronic configuration. Now it will be inside there we have 2. So this is the electronic configuration. 2 inside, then the second shell 8, the third shell 2, then the last shell 2. So these were free marks again. And this is why I'm saying science is one of the simplest subjects to pass. And therefore, I'm encouraging you, if you want to join the revision materials or my online tuitions for grade 12s and also for GCE, if you want to join and do revisions with me, you can join me and contact me on the WhatsApp number 0977 9241 75 0977 9241 75 if you want to be helped to pass. All right, so let's move to the next question. Question 2. Give the name group. Give the name, group, and period of element M. So this element M is calcium actually. Then the group, it is actually 2. You can even check from the periodic table. Then the period is period 3. You can also learn from here. If the element has 2 electrons in the last shell, it is in group 2. If it has 4 shells, like 1, 2, 3, 4, then it is in period 4. So number of shells, they represent period. Then the electrons in the last shell, they represent the group. So if you count the total number of electrons, it's 20, and it's for calcium. So that's calcium group 2 and the period 4. Then they're saying B, compare the reactivity of an atom of M and an ion of M. So they're saying between an atom and an ion of the same, which one is more reactive? Of course, an atom. So say an atom of M is significantly more reactive than the ion of M, because the atom seeks to lose electrons to achieve stability, while the ion has already achieved that stability. Yeah. So when you look at atoms, they are the ones that want to become stable by either gaining or losing electrons. Now, if an atom has already lost electrons and it has acquired noble stable configuration, there's no need to react. And if you want to compare it with its atom, definitely its atom will be more reactive than its ion. Okay, so we move to the next question, F4. Salts are substances that have many methods of preparation. Okay, then they're saying A, iron 2 chloride. Iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. Okay, then Roman numeral 1, which reactant should be in excess? Okay, so you want to form iron 2 chloride, right? So you are reacting substance X with hydrochloric acid to form iron 2 chloride. So between hydrochloric acid and iron and substance X, which one should be in excess? Substance X actually there. Then Roman numeral 2, they're saying why should the named reactant in A1 be in excess? Why substance X should be in excess? The reason is that to ensure that all the hydrochloric acid reacts completely. Yeah. So this one should be in excess to neutralize the acid so that the salt formed should not have the acid, which will be hard to remove. Then B1 suggests a suitable reactant as substance X. Which one can we combine with hydrochloric acid to form iron 2 chloride? It can either be iron it can either be iron metal, but I decided to use iron oxide, which is this one, or iron 2 carbonate. Iron 2 oxide or iron 2 carbonate. Or iron itself actually can react with hydrochloric acid to form iron chloride. Then 2, write a balanced chemical equation for the reaction between substance X suggested in here and dilute hydrochloric acid. So I chose iron calcium, iron carbonate, iron 2 carbonate. There reacted with hydrochloric acid to form iron chloride, then hydrogen gas and carbon dioxide. Iron 2 carbonate plus hydrochloric acid forms iron 2 chloride plus water plus carbon dioxide. Balance the equation there, because they said write balanced chemical equation. Then we move to the next question, which says B5, 10.5 grams of sodium hydroxide was reacted with dilute sulfuric acid according to the equation. So we have sodium hydroxide here plus dilute hydrochloric acid to form sodium sulfate and water there. Then they're saying balance the given equation. To balance this equation, write it as it is. Then you check sodium atom here, 1, here there how many? 2. So put a 2 there. You add a 2 there, they're balanced. So oxygen 2 here, plus 4 here, 6. So this side you have 6. Come here, oxygen 4 here, 2. Oh, sorry, I didn't put a 2 here. So we need to put a 2 here. Okay, so put a 2 here to balance it. So let's try to put a 2 there so that we can balance it. Yeah. So that is the correct answer because I didn't check properly there. So oxygen 2 plus 4 here 6, then here 4 plus oxygen 2 here 6, then you come to hydrogen 2 here plus 2 4, here hydrogen 2 times 2 4, then sulfur 1, then oxygen already considered. Then B1, use the balanced chemical equation to calculate the mass of sodium sulfate produced. So okay, we are given 10.5 grams of sodium, then they want to find this mass. So here 10.5, they want us to find this. Again, stoichiometry, as I told you. So you just do, okay, we have this one, which now we want to use to find this one. So what is given for this, use it to provide what? Use it to find what is needed. So say, okay, this one goes with that, right? Right. Then you say, okay, find the relative, because they gave you mass and they want also mass. So I said, find the relative formula mass for this one. It is 80. How? You use even this 2 here. Carry the 2 here. Use balanced one. So say, here 23 plus 16 here plus 1. It was giving me 40 times 2, 80. Then here, everything, you say this one is the one which gives. Here you total everything. Again, it was giving 142. That's what I found out when I said the sodium times 2, then plus sulfur, then plus 16 times 4 there. I found like 142. Then here you say, okay, now here we were provided with it 10.5 grams. Then here, what is it going to be? You say x. Then you cross multiply. You say 80 times x. You say, okay, 80x equals, then you say 10.5 times 142. You get something like, 1491. So here you divide by 80 to remain with x by 80 here. So x is going to be what? It's going to be 18.6 grams. Okay. Then here you say, okay, 18.6 grams is the mass of sodium sulfate. Simple like that, more concept, which people think it is difficult. No. Then two, what type of reaction is involved in the reaction? So you have the base and an acid. This reaction is neutralization reaction. Let's move to the next. B16 says an element A is in group 1 of the periodic table. Another element N is in group 7. So they are saying write one property of the compound formed when element A and N react. So an element in group so when an element in group 1 react with an element in group 7, an element in group 1 is a metal, an element in group 7 is a nanometal. So it's a nanometal and a metal. So the type of compound they form is called ionic compound, and the type of bond is ionic bond. So the property they have is that they have high melting and boiling point, one of the property. So it has high melting and the boiling point. Another property which you can mention is that they are solid crystalline. You can say they conduct electricity in aqueous or molten state. Okay, that's what you can say. Of course, there are many properties that have not been mentioned. Then B, what type of bonding exists in the compound formed between the two elements? I've said ionic bonding. Then C, how does the reactivity of elements in group 1 differ from elements in group 7? We'll say that the reactivity of elements in group 1 increases down the group, while that of group 7 decreases down the group. Yeah. Then B7 says metallic bonding occurs for most of the physical properties of metals. Metallic bonding accounts for most of the physical properties of metals. A, with reference to metallic bonding, explain why most metals have high melting points. 1. We'll say metals have high melting point because they have metallic bonds. Metallic bonds are formed due to electrostatic force of attraction between delocalized electrons and the ions. Yeah. So here, metals have high melting bonds point because they have strong, here I missed strong metallic bonds. Metallic bonds are formed due to electrostatic force of attraction between delocalized electrons and the metal ions. Then D, there's B, they're saying draw a diagram to show metallic bonding in zinc metal. So here is a diagram which shows metallic bonding. Then this is zinc ion and these are electrons, free electrons. So there's an attraction between these ion and these electrons, and they're forming a strong electrostatic force of attraction, forming metallic bonds, which makes metals have high melting points. Then we come to C. A learner carried out the following experiments. In experiment 1, 5 grams of powdered zinc, and in experiment 2, 5 grams of granules of zinc were each reacted with equal volumes of dilute hydrochloric acid, both of the same concentration, for 15 seconds. The reactions were not yet complete at 15 seconds. 1. In which experiment was at large? In which experiment was a large volume of hydrogen produced? Give a reason for your answer. So it will be experiment 1. Why? Because in experiment 1 they use powdered zinc, so you expect the reaction to go faster. So before 15 seconds in the first one, the reaction will go faster, produce more hydrogen gas than in the second one. At 15 seconds, it will not produce more. So experiment 1, because powdered zinc has large surface area exposed to the dilute hydrochloric acid, which leads to more frequent successful collisions between the zinc particles and the acid molecules per unit volume or time. Then 2, what would be the effect of reducing the temperature of acid in the reaction? This is why I say these guys, they don't reason properly. This question, they asked and give an answer 2 marks. They gave the space 2 lines. This one where they have given 1 mark, 3 lines. In one of the videos, I actually said these examiners, they are confused. I don't know what they do. Sometimes they give learners less space in a question that requires more marks, more solving, so that the learner will be confused to fail. That's not fair. Let us be fair to these learners so that they pass. This question 2 marks, in which experiment was a large volume of hydrogen produced? You mention, give a reason you give, then you give 2 lines. 2 lines, let me remove first. 2 lines, 2 marks. Then what would be the effect of reducing the temperature of an acid in the reaction? For 1 mark, you give 3 lines. Honestly, are these examiners logical here? No, they are not logical. They also contribute to the failure. So here, when they say what would be the effect of reducing the temperature of the acid in the reaction, the temperature, if it's reduced, the rate of reaction will reduce or decrease. So rate of reaction will decrease. You see, the answer here, the rest space was never used. Okay. Then B8 says the following diagram shows the laboratory preparation of a gas and its collection. B8. The following diagram shows the laboratory preparation of a gas and its collection. So we have this setup for preparing a gas. We have hydrochloric acid here being pushed there. Then granules of metal Y being pushed there. And then we have gas X being collected there. Okay. Then they're asking us a question. A, identify one error in the setup in the diagram shown. So one of the errors that I noted myself is that they did not use a trough of water. So there is no water trough to collect pure gas. Because if there is no trough here, that trough is used to also show the level of the liquid, that the gas that you have collected, and also to ensure that the gas you collect here is pure. But because there is nothing here, the gas which will collect here will be pure, and you won't know whether the gas has filled up the gas jar here or not. So there is no water trough in to collect pure gas. Then 2, gas X. Gas X here is actually hydrogen. Okay, why? Because this is an upward delivery. And you see, when I say one error in the setup in the diagram, for mentioning the error, 1 line. For identifying the gas, just saying hydrogen, 2 lines like that. Is that normal? No. So let's go. B, predict what will be observed if metal Y is replaced with copper. So when you are reacting copper with the hydrochloric acid or with an acid, no reaction will be seen because copper is lower in the reactivity series. So then no reaction will occur because copper is below hydrogen in the reactivity series and will not react with dilute hydrochloric acid to displace hydrogen gas. Okay. Then here, C, with reference to air pollution, compare the use of ethanol and the diesel fuels. So here we are going to say ethanol burns more cleanly and produces fewer pollutants like carbon monoxide and sulfur dioxide, while diesel produces more harmful emissions such as nitrogen oxide, and which cause more air pollution. Okay, yeah, so this is sulfur. We come to AB9. The following table shows some of the fractions of hydrocarbons obtained from fractional distillation of crude oil. Okay, in this table we have some of the fractions of hydrocarbons obtained from fractional distillation of crude oil. Fractions A, B, C, D, and then we have their boiling point ranges, these here. Then A, they're saying which fraction contains the longest chain? Give a reason for your answer. So the one which contains longest chain must have higher boiling point. So in answering here, we'll say fraction D here contains the longest chain because it has the highest boiling point range, and hydrocarbons with longer carbon chains have higher boiling points due to stronger intermolecular forces of van der Waals forces. Then B, decane, which is C10H22, can be cracked to produce hexane, which is C6, then H14, and one other hydrocarbon. So see, they like repeating these questions. You see, this question, we saw it in section A, and then they've repeated it in section C. This is why I always emphasize revising, guys, is one of the most important things ever to be done when preparing yourself to pass an examination. And this is why I'm encouraging you, if you haven't yet gotten the revision package, which is meant for past papers from 2015 to 2024, put together for you to revise, explained well, topic by topic, question by question, to help you to see how questions have been coming, how to answer them. If you haven't gotten yourself that revision package, then you are doing yourself a bad service. Actually, you are disservicing yourself. So for you, what to do is to contact me on the number 1977924175 so you can get that revision package and then revise quickly as you go in an examination with revision, knowing that after you have revised several times, then you'll be fully prepared to handle the examination questions. Then here they're saying deduce the chemical formula of T. So to do that, so decane is the one being cracked to produce this one. So they're breaking this one to produce this one and another hydrocarbon T. So for you to know the chemical formula for T, just subtract 10 minus 6, 4. So you have the one of this will have 4 carbon. Then 22 minus 14, you are going to have something like 8 here. So that is what is going to have hydrogen 8. So it will be C48H here. Okay, what have we done? We have said 8 decane, which is this one, can be cracked to produce hexane, this one, and one other hydrocarbon T. So I said 10 minus 6, 4, and 22 minus 14, 6 there. That's what you do. So T is this one here, which is butane. Okay, then they're saying to draw the displayed structural formula of T there. So T is actually this one here. So the structural formula will be this one. Carbon 1, 2, 3, 4. Then hydrogen 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then 3. Would you expect hydrocarbon T to undergo polymerization? Explain your answer. Okay, so they're saying, would you expect T to undergo polymerization? Explain your answer. Okay, so here would say yes. Why? Because we are saying hexene would undergo polymerization. Sorry, here I mentioned to say this one was hexane, of which that was an error. It is hexene, which is an alkene. So it will undergo polymerization. And the reason is that hexene, and here I repeated the error, it's hexene. So I can say hexene is an unsaturated hydrocarbon with double bonds between carbon atoms, and polymerization typically involves unsaturated hydrocarbons that contain a double bond. Because of that double bond there, so this one is hexene, hexene here, where there's A put E, hexene actually. Okay, then we move to the next question. Section C now. This is now the last part of the question here. So here they're saying answer any two questions from this section in the separate answer booklet provided. This year, guys, there will be no separate answer booklets. So you'll answer from the same question paper, section C, and also section A, and also section B. They've changed the format. They've changed the format of the exam. Answering will be in the same question. So C1, chemistry plays a big role in industry. A. Explain how chemistry is used in water treatment plant. Figure 2.1 shows a label from a bottled mineral water called Amenshi Vumi Pure Mineral Water. So we have Amenshi Vumi Pure Mineral Water, 500 milligrams. Ingredients: chlorine ion, then sodium ion, then magnesium ion, pH that. Then they're saying A1, state why Amenshi Vumi pure mineral water is not actually pure water. 2, if the mineral water was put in a fridge, suggest the temperature at which it would freeze. C, what are the basic units of matter found in the mineral water which has the label shown? Then D, most metals exist as compounds in their ores. Copper is extracted from its ore, copper to sulfide, this one here. Then 1, give an outline of the stages of copper production. Then 2, explain why copper conducts electricity. Let's begin answering. So question 1, where they said explain how chemistry is used in a water plant, in a water treatment plant. Answer will say chemistry is used to test water quality and remove harmful substances through processes such as chlorination, filtration, and pH control. Then the next question was like, state why Amenshi Vumi pure mineral water is not actually pure water. Answer, we are saying it contains dissolved ions such as chlorine, sodium, and magnesium, meaning it is a mixture, not pure water. Then C, it said, CB Roman numeral 2, it said, if the mineral water was put in a fridge, suggest the temperature at which it would freeze. Answer, we are saying it would freeze at approximately, below, I left something here, below 0 degrees Celsius. This is due to the presence of dissolved impurities, the minerals which cause freezing point depression. Then C, it says, what are the basic units of matter found in the mineral water which has the label shown there? So the basic units of matter are molecules and the ions. Okay, another question. D says, give an outline of the stages of copper production. Answer, the first stage in copper production is mining, which involves copper ore is dug from the ground. Then 2, concentration. Here the ore is crushed and concentrated by flotation to remove impurities. Then 3, roasting. So this one involves where, or this stage, in this stage, the concentrated ore is heated in air to convert copper to sulfide to copper to oxide and sulfur dioxide gas. Then stage 4 here is reduction or smelting. Copper oxide is reduced with carbon to produce impure copper. Then The last stage is purification. The impure copper is purified by electrolysis. Okay. Then D says explain why copper conducts electricity. They're saying copper conducts electricity because it has free or delocalized electrons that can carry electric charge through the metal. Then let's go to question C2. Elena added excess calcium carbonate, this one here, to 50 cubic centimeters of 0.1 more cubic decimeter of dilute hydrochloric acid, that one. Then A, construct a balanced chemical equation for the reaction, include state symbols, 2 marks. Then B, the volume of gas produced at that was that. Calculate the average rate of reaction over 2 seconds. Okay, 2 marks. Then 2, Elena repeated the experiment using that. Use the kinetic theory to explain why the rate of the reaction is slower with ethanoic acid than hydrochloric acid. Okay. Then 3, how would the Elena remove the excess calcium carbonate from the solution? Then C, methane, which is that one is a greenhouse gas. 1, what do you understand by the term green gas? What do you understand by the term greenhouse gas? Then 3, the percentage of methane by volume in the air is that. So calculate the mass of methane in that of air at room temperature and pressure. Okay, let's answer this one. So with the first, they're saying construct that chemical equation for the reaction includes state symbols. So this is a balanced chemical reaction between calcium carbonate and hydrochloric acid, and we have included state symbols here. Okay. Then C1, they said the volume of gas produced was that. Calculate the average rate of reaction. So rate, I used this calculation. Rate of reaction should be volume, which is this one here, over time. Okay, so the volume you get 24, you add divided by time 2 minutes. So now these 2 minutes, you can change it to seconds so that it becomes 0.2 cubic centimeters per second. Okay, so what we did, time is 24. I mean, volume is 24. Where there's volume, we put there. Time 120. We converted these 2 minutes into seconds. Okay, then we found the rate of reaction is 0.2 cubic centimeters per second. Then B, the learner repeated the experiment using that. Use the kinetic theory to explain why the rate of the reaction is slower with ethanoic acid than with hydrochloric acid. Answer. Ethanoic acid is a weak acid, so it partially ionizes, producing fewer hydrogen ions, fewer collisions with calcium carbonate particles or per second, so the rate of reaction is slower. Then we go to B1. How would the learner remove the excess calcium carbonate from the solution in A? By filtering the mixture to separate the excess solid calcium carbonate from the solution. Good. Then C2, C1, what do you understand by the term greenhouse gas? So answer, a greenhouse gas is a gas that traps heat in Earth's atmosphere, contributing to global warming. Yeah, like carbon dioxide and methane. Then C2, they're saying the percentage of methane by volume in air is that. Calculate the mass of methane in that cubic decimeter at that, okay, of air. So they're telling you that the volume of methane in air is that. So they've given you volume in percentage. This is what confuses learners. So the volume has been given in percentage. Then they have told you to say calculate the mass of methane in 100 cubic decimeter of air at room temperature and pressure. So what we will do is to know this percentage, how much volume is it occupying in that air. Okay, so once you know that volume, then you use room temperature and pressure concept in more concept to find the mass. So this is what we do. So here, convert percentage to volume. So say, okay, 0.0014% of that, you say now, this percent 0.00014 over 100 times this is what is happening. This over 100, because percent 0.00% means over 100, then off this means times. So this one times that, you get that volume now. Now, step 2 is to use molar volume of gas at RTP. So that room temperature they gave, you should know that at room temperature, 1 mole occupies 24 cubic decimeter. Okay, so you are going to say now, if 1 mole occupies this, how about that? So this is where you divide now this volume times 24, you get this number of moles. Then you calculate the mass. So you say methane, first calculate molar mass. Methane molar mass is 12 plus what? Plus 4, you get 16. Then mass is moles times molar mass. So number of moles is this times molar mass, you get that. Okay? So the number of grams is that. That's the answer. Then C3, the following table shows the soil pH ranges requires. The following table shows the soil pH ranges required by different crops for growth. Okay, so we have crop, these are the pH. Peanut, millet, sunflower, paprika, mango, these are their pH values. They've said a farmer plants peanut and millet crops. Only the peanut grows well. Okay? A. Predict the pH of the soil. Then 2, which other crop is most likely to grow well in the same soil. Then 3, suggest what would be done to the soil by the farmer in order for him to grow paprika. Then B, ammonium nitrate. This one is one compound which is added to the soil by many farmers. Explain why ammonium nitrate is added to the soil. Then C, the diagram shows part of nylon, a condensation polymer. This one here. They're saying 1, deduce the chemical formula of the 2 monomers in nylon. 2, draw the displayed molecular structure of the 2 monomers. So, D, fishing nets used to be made from natural fibers. Many nets are now made from nylon. Suggest one advantage and one disadvantage of using nylon rather than natural fibers to make fishing nets. So let's answer this one now. So predict the pH of the soil. So the answer is that the pH of the soil is likely to be 5.0 to 5.5, since only peanut which grows in this pH range are growing well. Good. Then 2, which other crop is likely to grow well in the same soil? Mango, because it also grows well in the pH range of 5.5 to 6.0, which overlaps with the peanut's range. Then Roman numeral 3, suggest what would be done to the same soil by the farmer in order for him to grow paprika. The pH of the soil would be increased by adding base such as lime, calcium oxide, or calcium hydroxide. Guys, I'm quite faster because I started a long time revising this video. I want to finish. But if you want clear explanation to this last part, which I'm going to do in my online tuitions, you can contact me on 09779241 so that you can be assisted if at all you are not going to understand, because I'm going to do this in my online class, because this question may also come in this year's exam. Why am I saying so? Because most of these questions, learners do not answer them. And what the examiners do, when learners have not answered a particular question well, they are likely to bring it back in the next exam, though with different tunings. Okay. So, B, explain why ammonium nitrate is added to the soil. Ammonium nitrate provides nitrogen, which is essential for plant growth, as it helps in the formation of proteins and the chlorophyll. Then, the last part is deduce the chemical formula of two monomers in a nylon. So we had the hexanodoic acid, which is adipic acid, that one, with the formula. This is the formula they wanted. Okay. And this is dioic acid that we are talking about, the nylon here. So this part and this part. So discover that this part is the one which gave us which part? This part here. So this part is this part here. Then these are coming from the acid. These are carboxyl group, CO. So to return them back, we just add OH so that they become COOH. Okay. Then this part here is coming from the amine. So it is coming from amine, which is for this one here. So you have seen this 6 here, CH26 is this part here, and this one here is an amine. Okay, so this amine group here, for them to complete like this, we wrote here, we added H. Where did the H come from? From water, because during hydrolysis or breaking down, or condensation polymerization, which leads to formation of nylon, water molecule is lost. So when we bring them back, these, we should add back water. So what we did was to identify this and then add hydrogen and the oxygen here, hydrogen and oxygen here to form this part here as the formula. Then also what we did again here is that to come up with this formula, we identified this and this. And then what we did, that oxygen, here we gave hydrogen and the oxygen. Then here we just gave hydrogen to form here hydrogen. Okay. Then they're saying draw the displayed molecular structure of the two monomers. Like this one, the structure is this one. Then for the next one, that one, the structure is that one. Okay, I'm sure I'm going to explain well in my online group, or even here on this channel if I'll have time. I'm also going to redo this. It's only that I'm recording this video at night and it's quite late, so I want to run fast and sleep. So this is the structure. And then they said suggest one advantage and one disadvantage of using nylon rather than natural fibers. Advantage: nylon is stronger and more durable, so nets last longer in water. Disadvantage: nylon is non-biodegradable, so it causes environmental pollution when lost in or discarded in the ocean. So guys, we have come to the end of this video. Thank you so much, and I hope this video has helped you. If it has, please remember to give it a like, share, and for more online detailed lessons to make you understand, contact me on the line 0977 92 41 75. For now guys, bye and see you in the next video. Peace.